Bright Tuty. Every student matters.
Hello dear students, the next topic that we will be studying about is the image formation through convex mirrors. For that, the materials that we will be requiring is, we will be requiring first of all a convex mirror, then we will require a mirror stand, a V-shaped mirror stand. We will be requiring a candle, and to do all the measurements we will be requiring a meter scale. Okay. So, now let us perform our actual activity. For this, the procedure that we will be following is as follows. First of all, we will hold a convex mirror in a V-shaped candle holder and light a candle and place it at a distance of 5 cm from the mirror. Now, observe the image formed by the candle in the convex mirror. You observe that the image is erect, diminished and formed behind the convex mirror. What does it show? That the image formed is virtual. Now, on moving the candle backward by 10 cm, again observe the image formed by the convex mirror and do it in taking the candle at different positions. You observe that the image remains erect and virtual, but its size decreases with the increase in distance of candle from the pole of the convex mirror. Furthermore, the virtual image formed moves away from the pole of the convex mirror, right. So, at whatever positions you were taking or placing the object, which in this case was a candle, we saw the image formation taking place, right. So, now I think you have got a better and practical idea of how image formation takes place in the case of a convex mirror. Got it? We can also study the formation of images by a convex mirror by drawing ray diagrams. Now, we know that convex mirrors were basically these type of mirrors which were painted from the inner surface, and the reflection of light was taking place from the outer bulging part. Now, in these convex mirrors, this was the principal axis, this was the pole, this is the focus, and this is the center of curvature. Now, all the objects that we will be placing on the left hand side, that is in front of the mirror, on the left hand side from the pole, that is the front side of the mirror, and this is behind the back side or the right hand side of the convex mirror. As we have done in the case of concave mirrors, here also we have certain rules which we need to follow while making the ray diagrams for seeing the image formation. Now, the first rule, this is a convex mirror, principal axis, this was P, this was F, this was C. The first rule states that any ray of light which is coming parallel to the principal axis, of course, will reflect, and it will reflect in such a way that it will appear to pass from the focus of the mirror. Fine. So, the first rule says that any ray of light coming parallel to the principal axis will appear to pass from the focus. Appear. Why? Because it is not actually passing from the focus, it will appear to pass from the focus after reflection from the convex mirror. This was the first rule that we need to follow. The second rule is just opposite of it. This was a convex mirror, this is the principal axis, this is the P, this is the F, this is the C. Now, what does this rule say is that if any ray of light is coming in such a way that it was actually supposed to pass from the focus of this particular mirror, then after reflection it will become parallel to the principal axis. So, any ray of light passing from the focus will become parallel after reflection, parallel to the principal axis, of course. Fine, this was the second rule. Now, third rule, as we have seen in the case of convex also, the same third rule applies here. In fact, third and the fourth rule both will be same. This was convex mirror P, F and C. Any ray of light which is going and striking the pole of the mirror will be reflected, making the same angle after reflection. Fine. Fourth rule. All right. Any ray of light passing from pole will reflect, making same angle with principal axis. Why? This is as per the law of reflection, which says that this was a normal, this is angle of incidence because it was an incident ray, and this is angle of reflection, which should be always equal. Fine. The fourth rule of convex mirrors is any ray of light, this was the P, this was the F, this was the C, any ray of light which seems to pass from center of curvature, this will be perpendicular or normal, and this will be reflected back along the same path. So, any ray passing from center of curvature, that is C, will reflect back along the same path. Right. So, we have these four rules which will tell us as to what exactly will be the path of ray. As in the concave mirrors, you can get this particular one question, you will be given a convex mirror, you will be given any ray of light, and you have to complete the path of ray. Either it will be from pole, this line will be given in the question and you will be asked complete the path of ray. You have to just reflect it, making the same angle. Next case, if it is going from the focus, you make it parallel to the principal axis. If it is going particularly from center of curvature, just put an arrow backward so that we can show that it is going back along the same path. And if it is parallel to the principal axis, reflect back in such a way that it appears to pass from focus. So, any of these rules can be asked in 1 markers. Fine. Okay. So, these are the various rules. Now, we will be studying about the image formations through convex mirrors. How and what kind of image will be formed if we put an object in front of a convex mirror? Remember the concave mirrors, we had 6 positions out there, but fortunately for you, happy news that over here we have only 2 positions. First position is anywhere between pole and infinity, anywhere between pole and infinity. So, this particular first position in convex mirrors, it includes all the 5 initial positions in case of concave mirrors, right? And the second position is at infinity. Let us see them both one by one. First of all, I will take the first position, that is I am taking this as a convex mirror, right? I am drawing the principal axis, this is the P, this is the F, this is the C assumably. Now, I have kept an object in front of this convex mirror. Now, we can see that in front of this convex mirror, we do not have any kind of expressions relating to what exactly is the position, because we have not marked any kind of point on this principal axis in front. So it may be anywhere in front. We will be taking all the examples. For example, at this distance I am taking, this is my object AB. Now for image formation, we will be looking at the rules. Only two rules or two rays rules are required. First, we will take that a ray of light is going from this object which is parallel to the principal axis. As per the rule, it will pass from the focus. This should be the arrow and this is the dotted line. Correct? Second rule, we say it is going from the pole of the mirror. If it is going from the pole, it will be reflected back, making the same angle. Now we can say that this was the first reflected ray, this is the second reflected ray, and they are not going to meet anywhere as they are going away from each other. They are diverging from each other. So what we will do is, we will extend up. This line we have already extended. This, when we will extend, we will see that these lines appear to meet at this particular point, and at this particular point we will say this is our image A dash B dash. Fine. So talking about the characteristics of the image, we see that the image is formed behind the mirror. Where exactly? It is formed between P and F. This was the pole, this is the F, it is getting formed in between. Next, nature and size of image. The image formed is virtual. Why? Because the light rays are not exactly actually meeting each other. Fine. The image formed is erect. Why? Because image is formed above the principal axis, and as compared to the size of the object, the image formed is diminished or reduced. Fine. So if we place this object here, let us take another example. Rather than placing it here, we are placing this object at this particular point. Fine. Right. Same thing. First ray of light will go from here parallel to the principal axis. After striking, it will become like this, it will appear to pass from the focus. Second ray of light, I assume once again passing from the pole. Now there will be a bit of change probably, but almost it will be same. It will be reflected back, making the same angle. Again, this is first reflected ray, this is second reflected ray. They are not going to meet anywhere as they are diverging to each other. What we will do is, we will again extend these rays, and the point at which they will appear to meet, now at this point we will get our image. Fine. Slightly different from the earlier one. Otherwise, approximately as per the position, no change whatsoever. Kindly observe, the image is still behind the mirror, right? On the right hand side, the image is still between P and F, the image is still virtual, the image is still erect, the image is still diminished. Got it? Same, wherever I will place the object, it will be same. That is why we have included all those points under one heading, that is anywhere between P and infinity. And what are the characteristics of the image? The image is formed behind, the image is virtual, the image is erect, and the image is diminished or reduced. Got it? Now when we are talking about infinity, this was our second position, that the object was placed now at infinity. This was a convex mirror painted from inside. This is a principal axis going. This was the pole, this is the F, this is the C. Now once again I will assume that object is at infinity, so I can't show the object. Fine. But all the rays coming from it we can show. Right. All these rays coming are assumed to be parallel to the principal axis. When they will reflect back, they will reflect back in such a way that all of them will appear to pass from the focus upon extension. Right. we can take any two ray of lights, and then when we extend them, as none of them are going to meet each other after reflecting back, as they all are going, they are diverging, they are all going away from each other, right. So when we extend them, we will see that the image is very small, it is formed right above at the focus. So the characteristics of image formed will be, the image formed will be behind the mirror, the image formed will be at F, the image formed is virtual, image formed is erect, and now the image form is highly diminished as compared to the size of the object. So let us write it over here properly, comparing these two. When the object is placed at infinity, then the image formed is behind the mirror, the image formed is virtual, the image formed is erect, and now it is highly diminished image. Now students, if you are able to see and observe and relate, we see that a convex mirror always forms virtual image, always forms erect image, always forms the image which is behind the mirror, and it is diminished or highly diminished. In both the cases we say that they are smaller than that of the object. Fine. So these are simply the two basic positions at which we keep the object, and we see when these objects are placed in front of a convex mirror, what kind of images are formed and where exactly the images are getting formed. Got it? So this is all simply all about convex mirrors.